Hello YouTube, welcome back to the channel. So in today's video, we're going to be looking at a Qdrant vector store. So a Qdrant is just a database for storing vectors. That's basically what it is. And in this video, we're going to look at specifically at multi-tenancy vector stores, whereby you can have you can have one collection, and within that collection, you can have multiple isolated vector stores, which are belonging to different clients or people who are using your application. So let's get into it and let's look at the different things that we're going to be covering in this tutorial. So we're going to look at what is multi-tenancy. You're going to go ahead and install all the dependencies that we need to run a Qdrant vector store. You're going to go ahead and download the data set. I'm going to pre-process the data, create multi-tenants or multiple tenants, and you're going to create a collection. And inside of this collection, you're going to have multiple tenants inside of the collection, and they are going to be isolated from one another. That's the whole concept of multi-tenancy. Then you're going to go ahead and insert data, learn how to query, and then at the end you're going to talk about the pros and cons of having a multi-tenancy setup within a Qdrant or basically any application. So let's get started. So the first thing is, what is multi-tenancy? So multi-tenancy is a very simple concept. Whenever you have multiple users using your application, sometimes you'd want to break down basically you have multiple users using your application. In this case, I'm going to talk about a vector store. So you have a vector store, one collection, and inside of that collection you can have multiple users, and each user has his own data being separated from the other. So if I have the same data, if I have a data within that database, nobody can access that data except me, right? That's basically what the concept of multi-tenancy is. So multi-tenancy refers to a software architecture model that allows a single instance of the software or a software application to serve multiple tenants or customers, with each tenant's data being completely isolated from all the other and only visible to him or herself only. So basically, you are also in the same data within the same storage point, but your data is not visible to other tenants within the application. It's only visible to you. Okay, so basically, let me just explain this using this diagram right here. So we have two users. We have John and we have Jane Doe. Right, so you can see that the data from Jane Doe and John Doe are completely separated. Jane Doe we use the payload to separate the data. So you can see the email of John Doe is john.doe at example.com, and that of Jane is jane.doe at example.com. So using that payload, we can separate and isolate the data. So all the data that has a payload of email of Jane Doe is only going to be visible to Jane Doe, and the ones which have a payload of John Doe at gmail.com is only going to be visible to John Doe, even though they are all living under the same infrastructure, but we have a data isolation using these strict rules. That's basically what multi-tenancy is. So in this case, I'm going to show how to set up a multi-tenancy and how to use it, how to create a database and other stuff like that. So multi-tenancy can be used in building in vector stores, can be used to build different applications such as chatbots, LLM agents, and so on, right? So let's get started with it. So I'm going to go ahead and we're going to install a couple of things. So I'm going to shift onto my terminal and let's see the couple of things that we need to install. So once I'm inside of my terminal, I'm going to go ahead and create a data set, a folder. I'm going to call this folder multi-tenancy. Okay, multi-tenancy, okay, and then press enter. So I'm going to change directory into, I'm going to actually remove that directory because we're going to use Poetry to create this. Okay, so remove -rf and then multi-tenancy, and then I'm going to remove that file, that folder. So once it's removed, I'm going to go ahead and create a new Poetry project. I'm going to call it multi-tenancy, and then I'm going to give it a folder inside of it called sections. Okay, and then just press enter. So that's going to go ahead and create for us that project. So I'm going to change directory into that Poetry project we just created. And once I'm in there, I'm going to do an ls, and you can see we have these files inside of it. So once I have that installed, let's go ahead and see a couple of things that we need to install. We need to run the second command from the screen. I'm not going to run that command because I've already run that command and it has that set globally. So it's just a Poetry command that you need to run. And the reason why you're running this is because it's going to go ahead. If I do an ls-la, you can see I have a folder. I don't have the env folder, but it should create an env folder. So let's run it and just see, make sure that env folder is being created. So poetry config, and then finally I'm going to go ahead and say virtual env. So I'm going to say virtual envs dot in project, and then hyphen in project, and then in and then hyphen project, and then you're going to say that to be true, and then press enter. So once you run that command, let me go here, ls-la. Now still the env file doesn't show, but it should be created right there. So we have an env file .env folder being created, and that's really important because it's going to be used by code editors to identify the libraries and other things that you're going to use. So let me try to open up my Visual Studio Code. So if I have that opened up, so yeah, once it's open up, let me just change the layout a bit. So I'm going to keep it right here. Okay, so that it's much easier to navigate. Okay, so once we have this folder created right here, right, so this is basically, I just change the directory into the poetry project created and open up VS Code, and we have this instance right here. Okay, so once we have that out of the way, I'm going to go ahead and install the libraries that you're going to be using in here. So I'm going to go in here. You can see the libraries you're going to be using: Qdrant client, you're going to be using LangChain, you're going to use LangChain, OpenAI, you're going to use Python.env, pandas, and all that libraries. So let's go ahead and make sure we have them installed. So I'm going to say poetry in poetry add, and then finally I'm going to add Qdrant underscore client. So this basically enables us to connect to a Qdrant database or vector store from Python. And I'm also going to go ahead and install LangChain. So I'm going to say LangChain. I'm going to install LangChain hyphen OpenAI. I'm going to go ahead and install also pandas. I'm going to, let me just take a look at the libraries I have here. I'm going to go ahead and install python.env. So I'm going to go back in here. I'm going to say python hyphen dot env, and I'm also going to go ahead and install datasets, which is also a dataset library you're going to use to download the dataset that you'll be working with. And I'll just talk about the dataset whenever we get there. So I'm also going to install interactive Python kernel. So I'm going to say interactive datasets. I'm going to interactive Python kernel. This will enable us to run a Jupyter notebook within VS Code. Okay, so once I have all that done, I'm just going to go ahead and press enter, and that's going to go ahead and install all these libraries that we need. You can see we're going to install it within the .env folder, which is what this command we wrote a command. This is what this command simply create for us. Okay, so that's basically it. So basically this enables like your text editor like VS Code to be able to pick a virtual environment, and I will show you how we pick the virtual environment when we're using Jupyter notebook, so don't worry about that. So let's give this a bit of time for this to install. Good. So once we have that library, those libraries installed over there, we are good to go. So now let's talk about the other things right here. So we're going to go ahead and talk about the data set. So we're going to be using a MongoDB movies data set. So this is just a data set that has information about various movies. That provides information about the actors in the movie, the directors, the movie title, the plot of the movie, and also provides us an already embedded version of the movie plots. So with these embeddings, you can simply just insert them into our vector database and then be able to query them, right? So basically, this guy just took the movie data set and just created embeddings of the movie plot or the movie plots, and then simply stored it in a CSV file. You're going to download that CSV file and be able to use it, so we don't have to actually waste our own tokens, or basically, because you're going to be using OpenAI, you're not going to use our own tokens to create embeddings for this. These embeddings are already created. We just have to insert them into our Qdrant vector store. So good. So let's go ahead after download this data set, and then finally we'll go ahead and process the data. So let's go ahead and begin working on it. So good. So mention if you if I don't know if you remember, I talked about an env file. This is the env file right here. That you're going to be .env file folder. Sorry, not file folder. Okay. So once we have that, I'm going to go ahead and create another folder, and I'm going to call it basics. Basics. You can call it anything you want. I'm going to call it basics, and I'm going to create and I'm going to call main.ipynb, right? Jupyter notebook. So once I have Jupyter notebook created, this should take a second to load up, and so you can see right here it's trying to detect the kernel that you're going to be using, and it might take some time, and you can see it didn't detect any kernel. Okay, and that's the reason we installed the interactive Python kernel inside of our poetry, right? So now that you have that done, let me just go ahead and select the kernel that I want to use. So I'm going to click on this one. I'm going to say, so once you click on select kernel, I'm going to go ahead and say I want a Python environment. So click on that, and then go ahead and select this .env. Remember, this is the file that we created using that poetry command. So click on that, and that's going to go ahead and select for you the rect environment that you want to use. So now that you have the rect environment selected, you're going to go ahead and download the dataset that you want to use, and then finally be able to pre-process this dataset. So I'm going to say from data sets. From data sets, I'm going to go ahead and import load underscore data. Okay, load data set, just like that. And I'm also going to import load underscore data set, just like that. I'm also going to go ahead and import pandas as a PD. Okay, so once I have those imports as done, I'm just going to press enter. Good. So once we come up here, I'm going to say data, and this data is going to be what you're going to download from the using the load dataset library that you just imported. So load datasets. You're going to go ahead and pass the name of the data, which is Mongo. Sorry, let me clear this out of the way. MongoDB / and then finally you're going to say embedded underscore movies movies dataset. That's the dataset that you want to download. And then from there, I'm going to convert this dataset into a pandas data frame. So I'm going to say pd.data frame, just like this. And then finally, I'm going to go ahead and pass in the data. You're going to only get the training part of this data, not the whole data. So I'm going to say train, just like this, train. Okay, so good. So once I have this done, I can just go ahead and simply do a df dot head, so you can see the first two rows of that column of that data, the first two rows of that data frame. So I press enter, and that's going to simply download the dataset, convert it into a Python data frame, and then finally get us the first two rows of that dataset. Okay, this may take a bit of time because depending on your internet speed, because you have to download something from the internet, right? So just be patient. And once that goes through, you can see we have it right here. So you can see we have the different columns right here. We have the plot column, we have the maximum mflex comments, we have the poster, we have the link, we have the cast, and all that information. You can just scroll all the way here. Just scroll all the way here. You can see we have the embeddings and stuff like that, and these embeddings are created for us by default, so we don't have to do anything to get these embeddings, and that's the beauty of this data set. So we don't have to actually use our OpenAI API keys to create these embeddings ourselves, because they're already created for us. So good. So once we have that in there, I'm going to go ahead and simply say df.isNA, and now we're going to check for any missing values right there. So if I press enter, that's to return to me a list of all the missing values that we have. So you can see we have some NaN values right here, and you can see this column has a lot of NaN values. So I'm actually not going to work with this column. Okay, so I'm going to find a way to get rid of that column. So good. So once we have that done, we check. You notice I have some missing values. Let's check the shape of this data frame, so we can know how many rows and columns we have. So we have this amount of rows and this amount of columns, right? Good. So let's check the dimension size of this data set. So I'm going to check the dimension size of this. I'm going to say df, and I'm going to go ahead and get the embedding status, the embeddings, right? So it's called plot embeddings, right? Yeah, it's called plot embeddings. So later on, I think we'll need to have to change that name. Okay, so you can change it to something else instead of, you can just call it embeddings instead of plot embeddings. So now let's go ahead and actually do that instead. So I'm going to say df dot rename, okay, rename, and you're going to go ahead and decide which columns you want to rename. So I'm going to say columns, and then equals to, and then provide a list of columns that you want to rename. Okay, so we pass in a dictionary right here. So we provide the column that you want to rename. I want to rename the plot underscore embeddings, right? It's called plot embeddings. Okay, it is this right here. So plot embedding, we're going to rename it to something else. So we're going to rename it to a new value, and this new value is going to be called embeddings, just like that, embedding, just like that, with a G. Okay, so once we have that, then we're going to also use the in place key. So in place, and you're going to say in place is going to be true. So the reason why we are setting in place is going to be true because we don't want to reassign this back, this operation back to the variable ds. So in place to do that for us in the background. So good. So once we have that done, you can just go ahead and say df dot head, just like that. And just you can get the first two rows. So good, print that out, and let's see what we get. So now if I scroll all the way here, you can see now it's not called plot embeddings anymore like it was previously. Up here it was called plot embeddings. If I scroll all the way here, so I'm just scroll all the way here, it was called plot embeddings, but now it's just purely called embeddings, right? That's what it's much easier for me. It makes more sense to me that way. Okay, so once we have this done, we also check the length of this. So let's go, actually what I want to do is just check the length of one specific embedding, not all the embeddings. Okay, so one specific embedding should give me the dimension of the embeddings that were used for this. So okay, let me see. Okay, now we change it to, it's not going to work anymore because it's now called embedding and not plot embedding. So if I run this now, it should return to me now a value of the length of each individual embedding. You can see it is 1536. So that is the same embedding size that is used by OpenAI embedding model. So we're going to use the OpenAI to be able to work with these embeddings because they use an embedding model that generates an embedding dimension of 1536. So we're going to use a model that can give us that dimension as well, and which is an OpenAI model, which I know of. Okay, so now that we have that done, so we have look at our download our data. We have pre-processed the data into what we want to, and now let's go ahead and create multi-tenant. So we talk about the users. Let me just go all the way back here to this diagram right here. So we have this right here whereby we have the payload, and the payload can have like a username or something that differentiate the different users, and which isolation is done, isolation of data is done. So in this case, I'm going to go ahead and split our data set into two parts. So we're going to have another field. We're going to read another column. We're going to call this column data. I'm going to call it data set. You're going to split this into two the individual columns. We're going to call this MongoDB underscore embedded underscore movies, and then I'm just going to underscore one. So you're going to split our data into two parts. The first one will be have a column called data set, which is going to be MongoDB underscore embedded underscore movies underscore one, and the other column is going to be MongoDB embedded underscore movies underscore two. Okay, so that's basically, you can think of it like that's basically, those are the users, right? So our data is owned by two different users, one being MongoDB embedded movies, and another one being MongoDB embedded movies 2, right? So good. So once we have that done, we have created a new column. So if I do df.head and I pass 2 in, we should get a new column. Okay, so if we get a new column. If I scroll all the way here, we have a new column, and you can see all the values in this column have the MongoDB underscore embedded underscore movies 1. So now what you want to do is to now make some of them have embedded MongoDB embedded underscore movies underscore 2. So let's do that. So this data set, if you look at its size, is about 1500, right? 1500. So if you divide that by 2, I just did a rough estimation. So I think I'm going to say data frame data set, which is a column data set, which is a column that we just created, and I'm going to go ahead and get the sum of the columns. So I'm going to go ahead and simply say from 726 onwards is going to give it to be MongoDB underscore datasets 2. We're going to change that value. So if I go all the way up here, okay, let me just scroll all the way down here. So copy this. Once I have this copied, I'm going to scroll all the way down here and then simply paste it in here. This is going to be a string, right? So put it in the double quotes, and I'm going to change this to be 2. So all the values are going to start from 726 all above are going to have MongoDB underscore embedded underscore movies underscore 2 in their column as their data set value. So I'm going to say df dot I'm going to just print ilog, and then let's go ahead and try to get 126, right? So if I print that, now the data set column should return to us MongoDB underscore 2. But if I print anything below that value, I can just go ahead and say, let me change this change this to 5, and let's see what we get. And now you can see it should be 1 instead of 2, right? So we have split our data set into 2 and then created multiple users. Just kind of, you can think of it like that. So we created multiple users using that concept, right? So good. So now our data set has 2 different of these. So this could be the users. You can create anything you want. So you can actually create users and then assign different roles to each different user, right? Each row of the data set to each individual user. Good. So let me just go ahead and clear this. There's an output right here. Good. So once we have that in place, now I'm going to go ahead and see what next we can do. So let's go back and see what's next on the list. So go back here. We have pre-processed our data. We have created multiple tenants. So basically, which is just splitting the data amongst tenants. Good. So now I'm going to go ahead and looking at how to create collections inside of our MongoDB, instead of our Qdrant, the Qdrant vector store. So good. So now we need to go ahead and create the collection. And to create a collection, we need a couple of things. The first thing we need is to have a Docker container running, which is going to run our Qdrant database or vector store that we're going to go ahead and connect to. And from there, we can create a collection on that vector database. So I'm going to go back in here. I'm going to go ahead and create a Docker compose file. So you need to have Docker for this, right? So if you don't have Docker, you can go ahead and use the online version of Qdrant if you want, but I'm going to be using the Docker version of this. So let's go ahead and do that. So I'm going to go ahead and create a Docker compose file. So Docker, let me just get this right. So let me say Docker hyphen compose.yaml. You can say YAML with an A or YAML without the A. So whatever works for you, right? Good. So once we have this, I'm going to go ahead and specify a couple of things that we need to create this to work, right? So the first thing I'm going to specify here is the version of Docker Compose I'm using. So I'm going to use version, I'm going to use version 3.8. So feel free to use any version that works for you. I'm going to be using 3.8. Sorry, this is actually 3.8. Okay. And I'm also going to go ahead and pass in the services. You're going to have a list of services. In this case, you're going to have only one particular service, and this service is going to be basically the quadrant service, right? So I'm going to say service. You're going to go ahead and say quadrant. So that's basically the service you want. And I'm going to go ahead and pass in the profiles for this service right here. So profiles, and then finally I'm going to go ahead and say the following. So I'm going to say local underscore quadrant, just like this. You can call it anything you want, but I'm going to call it local quadrant. Okay, so you seem to have an error right here. It says incorrect type specified Docker compose.yaml. It says a version of Docker compose document. So I don't know why it's let's see why you're getting that error. Okay, let me just say 3.8 without this. That should also work, but let's see. Let me just cover it in single quotes and let's see if it's gonna work. Yeah, so let me close this file up and then have it open Docker compose.yaml. So open it up again. Just rename this file again. So let me just rename it to YAML with an A. Let's see if that fixes it. Okay, so now that fixes it. So I have to use a YAML with an A for some reason. So the local quadrant, and I'm going to go ahead and pass in the image that I want. So I'm going to say image, and the image is going to be quadrant quadrant, and then finally we're going to use the latest version of this image. Okay, and then finally we're going to go ahead and specify the port number. So we're going to map port 6333 on our local host to the 6333 on the guest machine. So I'm going to say port basically this is going to be in here. I'm going to say port 3666. So this is going to be on like your physical machine, and then this is going to be right on the Docker container. So you're connecting these two ports, and it's going to enable us to connect to this port within our application. So it's very important that you specify this. Okay, so if you use a different number right here, then keep that number in track. In your head, you're going to use that number just in a second. Okay, but by default, just keep it to be 336 because the quadrant is known to run on that specific port. And you're going to create a volume right here. So when we say volumes, you're going to have only one volume. In this case, you're going to have dot/quadrant underscore data, and you're going to map that to /quadrant /storage, just like that. Okay, so that's basically, so quadrant underscore data is going to be mapped to quadrant /storage on the Docker container, and this is going to be on our local machine. So this get spelling right, so it's actually quadrant, just like that. Okay, good. So once we have that there, we are good to go. So now we need to go ahead and start this container up. So to do that in Docker Compose, it's very easy. So we need to go into our terminal, clear the terminal right here, and make sure you can see that file right there. It's a Docker Compose file. So we're going to say docker-compose, right? So compose, and if we're going to say -- profile, right? You're going to say profile, and then you're going to go ahead and say load underscore quadrant, just like this, and you're going to say up, and you're going to run this in detached mode. So I'm using this right here, and the reason for this is because this is what you're specified here, local underscore quadrant. That's basically why I'm specifying this right here. Okay, so once we have that done, I'm going to press enter, and it's going to go ahead and run, and we have an error. They say Docker Compose is invalid because a service. Okay, let me get that right. So it's actually services and not service, right? So it's services. My bad. Okay, so once we have that done, clear the terminal, and then let's run this one more time. So now it says that because ports. Okay, that's actually ports, not ports. So ports. Okay, so I hope I didn't make any more errors. So let's try this out, and let's see. That should start for us a Docker container, and you can check if it started by running the following command. You can just go ahead and say docker ps, and then you can say -ls, and that should show that container has been running, right? So you can see it right here. Right, so I created this container a while back, and I still have it running because I'm still using it. So in your case, my set started like 2 seconds ago, 1 minute ago, whatever, right? So clear this. So now that we have that Docker container running, right, now we can connect to it from our Python application and be able to, from there, be able to create our collection. So how do we connect with this container from our Python application? So we go back in here. I'm going to close this for now, and I'm going to go back in here, and can just keep a markdown right here, and you can just go ahead and say connect to quadrant container, Docker container, whatever works for you, right? So I'm going to go in here. I'm going to go ahead and import a couple of things. Say from quadrant underscore client import the following. So I'm going to import quadrant client, which is just a class that we're going to instantiate just in the middle, just in a second. You're going to also go ahead and say going to import also model. So we're going to say from Qdrant underscore client dot models. I'm going to go ahead and import distance, and I'm also going to import vector params, just like that. So press enter, and that should have those two things imported. So once we have those two imported, we're going to create a client variable that's going to go ahead and store our Qdrant connection. So we say Qdrant client. You're going to go ahead and pass in the location, which is just basically where you want to connect. In this case, you're going to connect to local host at port 6333, and port 3633 is what we specified here, this number right here. So if you use a different number, then keep that in mind here as well. Okay, good. So once I have that created, I'm going to go ahead and press enter, and that's going to go ahead and execute that and connect us to our Qdrant database. Good. So once we have that connection being established, you're going to go ahead now and be able to create a collection. So to create a collection, we're going to go ahead and simply say client dot create. I'm going to use recreate instead of create, and the reason why is because people might run this code a couple of times because maybe they get an error. So I'm going to be using the recreate instead of create, because the recreate will create it every time you run the code, create a new collection, right? And not give you error saying that the collection already exists. So if you are sure of what you're doing, then you can feel free to run the create collection. But if you are just testing things out, you can use the recreate. Okay. So I'm going to go ahead and say collection underscore name, and the collection name is going to be basically, I'm going to say MongoDB underscore movies. Sorry, I'm going to say MongoDB underscore embedded underscore movies underscore collection, just like that. So MongoDB underscore movies underscore collection, and I'm going to go down here, and I'm also going to pass in the vector configuration. Say vectors underscore config, and it's going to be equals to a variable that you're going to create just in a second. For now, let's leave it to be a string, and let's go down here, and you're also going to go ahead and pass in another parameter right here, and this parameter just enables us to have parallelism. Okay, because I'm going to say shock underscore number is going to be equals to 2. So what this simply does is that it creates two processes whenever it's inserting data into our collection. You're gonna go ahead and create two parallel processes that are going to be running in parallel at the same time, right? So this number could be in between 2 and 3. That is what it's reset by the official documentation. So by default it's 1. So I change this to be between 2 and 4, right? So again, it's in between 2 and 4. You can use 3 processes, you can use 4 processes that are running at the same time, depending on how much powerful your computer is, right? So good. So once I have this, I'm going to go ahead and create a new value up here, and this is going to be vector underscore config, just like this, and this is going to be basically a Python dictionary. In this dictionary, I'm going to go ahead and specify a key, right? You're going to call it plot underscore let's go embeddings, plot embedding right here, and this is going to be a Python dictionary. It's going to be an instance of vector params that we just created, which just imported, which is this object right here, this instance right here. And you're going to go ahead and pass in, if we're going to pass in distance, and this is going to be equals to distance distance dot, going to say cosine, just like this. So this basically is going to enable us to perform cosine similarity whenever you're performing a similarity search of our vector store, right? So I'm not going to explain this in depth what a cosine is, what's a cosine similarity search. There are other similarity searches as a Euclidean similarity search. You can also use the dot product similarity search and stuff like that. But the most common that people use is the cosine similarity search. You're going to be using that as well. So I'm going to say it's also size of these vectors you're looking for. So size is going to be equals to, you're going to simply say the length. They're going to say let me get this right, length of our data frame. You're getting the embeddings, and you're getting the very first instance of it. You're getting the length of it. And if you scroll above here, we did this earlier on, and we saw that the dimension is if I scroll, if I can see right here, is 5,000 100 and say 1536, right? That's the dimension of that vector. So we're going to use the same value right here as the dimension of the vector, because that's what you're basically inserting it in there using this value right here. So df embedding, you're getting the first one, you're getting the length of it, which is 1536. So we're going to go ahead and copy this value. So copy this value. Let's make sure we run this all. And once we have that value copied, you're going to go ahead and insert it right here. So insert it right here, and then we can run this as well. So run this cell as well. Okay, good. So once we have that running, we got an error right here. It says unknown argument. Okay. I said shark number instead of shard number. Okay, my bad. So that's shard number and not shark number. Okay. I don't know. I'm thinking of sharks. Okay, so once I have that defined up there, we are good to go. So now we're going to insert data into our collection, but which kind of data are we interested in? What data are we interested in, right? So that's what you need to specify right here. So now that we have that collection created, we are going to go ahead and specify which columns or from our data frame that we want to use to insert data into our collection. So you can just go ahead and say df.columns, df.columns, and then print that out. It's going to return to me a list of all the available columns. So the columns that I'm going to be interested in a couple of columns, right? Not all columns. I'm going to say I'm going to create a variable columns underscore of underscore interest is going to be equals to a Python list, and inside of this list you're going to insert some values from here, right? So I'm going to copy some of these values, copy some of those values, and let's go ahead and insert those values in there. So we're going to keep the movies, we're going to go ahead and keep the plots, we can keep number of these guys as well, we can keep the title, we can keep the cast, yeah, we can keep the full plot, we can keep the directors, we can keep the IMDb ratings, we can keep the embeddings. We don't want the embeddings, and I'll show you why we don't want the embeddings at this juncture. And we don't want this as well because I showed you earlier on it has a lot of missing values, and the end values can just cause us a lot of issues. I don't want the types as well, so get rid of the types as well. I can keep the awards part, I can keep the rated section. No, I don't want the rated section as well, so I can get rid of the rated section as well, so get rid of that. I can keep the journal, I can keep the runtime. I don't want the runtime information as well. I can keep the countries, I can keep the writers, I can keep the language, and I can keep the data set. So that's basically what I want to keep, right? So I can just go ahead and format this a bit. Okay, so format, I just want 2 on each individual line, just 2, 2, 2. Okay, and then okay, here, okay, I want 2 as well here, and I also want 2 here as well, so 2 as well. Okay, good. So once we have that in there, you can just format this a bit, make it look prettier. Okay. Okay, so once we have it, you can also format this as well on a new line, and then finally I can bring this guy all the way up here, just like that. Good. So that's basically what the information that I want to work with. So once we have this in place, we can go ahead. So we have, let me just check one more time. We have the plots, number of these guys. Okay. We have the posters, we have the title, we have the cast, we have the full plot, we have the directors, right? We can keep the directors if you want to. We have the IMDb ratings data, we have the awards, we have the journal, we have the countries, okay, we have the writers, we have the languages, and then finally we have the data set. So good, we are good to go. So I'm just gonna go ahead and run that cell, and once we have that cell done, run. Also, I'm going to go ahead and now I'm going to go to DF, and I'm going to go ahead and grab the columns of interest just to demo something. So I'm gonna just copy this from here and save on time. So columns of interest, and I'm going to say dot to underscore dict, and let's see what we get back from here. So this is basically going to convert all these columns right here into a Python dictionary. That's what this method here does, and this can take a bit of time, so you have to be a bit patient. So this okay, so now that went fast, okay, bit, so you can see all that information right here. Okay, so we're going to use this in a second. So I just want you to understand what you'll be doing later on when you're writing the code, so that you are not just copy pasting or typing along. So you can see what this method actually does. So let me, once you're okay with that, I'm going to clear this. I'm also going to go ahead and show you something. I'm going to say for id in id comma df underscore vector in df dot iter rows, and I'm going to go ahead and I can go ahead and print the following. So I can go ahead and print basically the embeddings from each of these. So I'm going to say df underscore vector, and I'm going to go ahead and grab the embedding. So embedding, just like that. So if I run this, it's going to go ahead and print for me all the embeddings from each individual row. And the reason why I'm showing you this is because you're going to use this just in a second. So just keep it in mind, okay? You don't have to really understand what you're trying to do at the moment, but just keep it in mind whenever we get to that point of using it, which is just in a second. So you can see it brings out all that information onto the screen right there. So I can just stop this right here. I can stop that execution, and I can clear this cell output. Let's just wait for this to stop, and I can clear that cell output. Okay, so now that's done. I can just go ahead and clear this right here. So clear that. Okay, so now that we have a new cell, what I want to do, for some reason it still keeps this information right here, which I don't want, but okay, so once I have that cleared out of the way, so I'm going to go ahead and say import. I'm going to import from Qdrant, right? From Qdrant underscore client. I'm going to say from dot models. I'm going to go ahead and import point struct just like this, and then have that run that cell. So once I have that run, I'm going to go ahead and import a couple of basically let me get the spelling here right. So it's point struct, right? So point struct. Okay, so once I have that running, what I want to do is also I want to go and now insert data, which is what we call upsort in Qdrant, upsort data into the database. So you can just think of this as an insert operation if you're coming from a relational database. So I'm going to go ahead and say specify the collection underscore name, and the collection name is going to be basically just say MongoDB underscore MongoDB, right, underscore embedded underscore movies underscore collection, just like that. So that's basically what the collection name is. So we are passing the collection name. Now you have to go ahead and specify what we call points to basically these are the vector points that we want to insert into our database. So that's basically we're going to create a list of this, and you're going to use a Python list comprehension to be able to iterate through each of those rows. Like what this for loop right here, we're going to now use it instead of list comprehension. So we're going to create an instance of point struct that we just imported. All right. So we're going to go ahead and pass in the ID, and if you go back in here into our diagrams that we're using right here, we have this ID. So we're going to pass in the ID, the payload, and the vector. The vector now is the embeddings that have been created, right? So let's go ahead and do that. So I'm going to pass in the ID, and the ID is going to be ID. So don't worry about where I'm getting the value ID from. I will show you just in an instance where we're getting this ID from. Basically, we're getting it from here. So basically, we're getting this ID from here whenever we iterate through this. Right? So passing the ID, you're going to pass in the vector, and this is going to be equals to a Python dictionary. And why are we using a Python dictionary? Because you're using a Python dictionary because if let me want to show you something up here that you might can help you understand that. So if you look at this vector config that we use down here, it's a dictionary. It has this key. So we are going to pass in a dictionary saying this key and assigning it to a vector. That's what you're trying to do. So I'm going to say this right here, and you're going to go ahead and say a vector. So I'm going to put a list right here and paste what I just copied, and this is going to be equals to, we're going to say df underscore vector, and you're going to simply say you're going to get the embeddings part of it, embedding. So that's basically it. And then finally, also we're going to go ahead now provide in the last thing. So let's look at the back at the diagram. So we have already the ID, the vector. Now we're going to add in the payload, and the payload is going to be everything else. So you say payload is going to be equals to, and you're going to say df underscore vector, and then you're going to say columns of interest. So columns of interest, let me just copy that value from here. So yeah, columns of interest, copy that, and you're going to use it right here. So columns of interest, and you're simply going to use dot to underscore dict, just like that. So this is the same thing that we did up here, right? So I just want you to understand why we are using that, right? Okay, good. So once we have that in there, now we're going to now write the for loop for this, right? Because it's going to be a list comprehension. So for each of the rows inside of our data frame, you're going to be creating this point structure. So I'm going to say for ID, which is what you're using right here, and then you're going to say df underscore vector in df dot iter rows, just like this. So that's okay, let me get the spelling there right, rows, right? So that's basically what we need to do right here. Good. Yeah, so that's basically what you need to do. And before we run this code, there are some missing values that we currently have. So if I go up here and I do df dot is and a, and then just run this, there are some missing values that we currently have inside of our data frame. So what I want to do is to get rid of it. You can see we have a dot sum. Let me use dot sum to get that. Let me just get the sum of, I don't want this data frame of true and falses. I just want the sum of those. Okay, so now there are some missing values, and let's see how we need to replace this missing value, because if you try to insert these missing values into our data frame, it's going to lead to an issue. So let's go ahead and insert remove these data frames from the selected field. So I'm going to say df is going to be equals to df, and I'm going to say df, and then finally you're going to say full plot. So full plot has some missing values. Okay, so we're going to go ahead and say dot not and a. Okay, so it's going to return to us none and a values. So that, like the non missing values. I'm also going to use also going to say embedding, and you're going to say .na. That's going to return to us also now removing all the missing values. Okay, so that's going to run, and let's see, once this is run, it's going to remove all the missing values that we from the columns that we are going to be interested in. So once we have that, now let's run this to insert data into our collection. So this can take a bit of time depending on, okay, so okay, iter rows, I think it's called iter rows or iter row. Let me see, let me just adjust this a bit. It's called iter rows and not iter row. Okay, so let's run this one more time, and hopefully I have no more typos in there. So once this run, we should insert the data now into our collection for us. Once we have the data into the collection, what next? So once we have this, we can use it to create chatbots. We can use it to create can you perform semantic searches, which I'm going to show you how to do just in this video. Maybe in the next video I can show you how to actually use this to create chatbots of different users and stuff like that, right? But for now, I'm just going to show you how to perform a semantic search. So good. So once you have that done, now let's go ahead and perform the cosine similarity search. So let's say cosine, cosine. Now let's say semantic search, or semantic search. Okay, so we're going to use it to perform semantic search. So I don't know why. Let me just cut this from here, delete this all. I think I needed a markdown, so okay, paste that in there. Okay, and then run this. Okay, so once that's created, now let's go ahead and use this to perform cosine similarity search. So to perform cosine similarity search, the first thing we need to do is let me just go back in here. I think I have a diagram to explain this to you. I've already done this already. I've already upset data. Now querying the data. So we are querying the data. So to be able to perform a similarity search, we have embeddings, right? You have already created embeddings. Now, when the user asks a question, the question is going to be in the normal human language, like text, the normal text, the natural language, right? So what you want to do is to convert this natural language into a vector and compare this vector of the user's question to existing vectors that we have stored in our data, in our collections, and then find out which ones are more similar, and then return the n number of similar searches. So we need to go ahead and be able to convert the user's inputs into a vector. So we're going to do that using OpenAI. And why are we using OpenAI? Because OpenAI returns the same embedding dimension of 1536 as the embedding dimension that has been used, as I shown you earlier on. If I scroll all the way up here, I think I have it here, right? Use the same vector embeddings dimension, so we need to have the same dimensions. Okay, good. So once we have that done, I'm going to go ahead and import a couple of things. So import OS. Once I have OS imported, I'm also going to go ahead and import .env, which is a Python library that we installed. Also, then I'm going to go ahead and simply load this .env values into our environment variables. Basically, load the values from the .env file, which you need to create just in a second right here, into our operating system env file. So exe, and then you're going to say .env. Okay, and if we need to go ahead and also say percentage sign, and then say .env. So say percentage and say .env, just like that. And for sometimes you might run this code multiple times, and if you run it multiple times, you can add the reload capability, which is just using the reload right here, reload, and then finally say ext, and then say .env. That's basically it. So once I have this, I run this cell, and that should now load in any env files if we have, but in this case we don't have any. So let's go ahead and create an env. You can see no .env file. So let's go ahead and create one. So we can say .env, and then once we have this file created, instead of this file, what you're going to do is simply say OpenAI underscore API underscore key, and then finally it to be equals to, and then the Open API key will be somewhere here, right? So let me just get my Open API key and add it to this environment variables, and then add it to this file, and then back recording, because I don't want you guys to see my API key, and that's for solid reasons, right? So let me just get that and then add it in here. Okay, so I've just added in my my API key instead of my .env file. So now let me just rerun this cell again to load in the values from the env file. Okay, so once that's being loaded, okay, now it's got loaded successfully. Now let's go ahead and import the OpenAI embeddings to be able to convert a user's question into normal embedding. So we'll say from langchain underscore OpenAI, I'm going to go ahead and import OpenAI embeddings, right? Embeddings, just like that. I run that cell, and that's going to import for us this OpenAI embeddings library. And we're going to use this to embed, create embeddings. So I'm going to say create a variable set and critical embeddings is going to be equals to an instance of the OpenAI embeddings, right? So create an instance of this and then run that cell. So once you have an instance of this created, now you can go ahead and basically have a user query. So the query can be anything. So the user query could be basically any question from the user. In this case, I'm going to have a simple question. I'm going to ask it for movies with IMDb rating of 6.3 and genre of action movies, right? So run that. So that's going to create basically a Python string. Now we're going to create now convert this Python string into a vector query. So I'm going to create a query vector, and this is going to equals to embeddings dot query dot embed underscore query, and in here we need to go ahead and pass in the query that you want to embed to create an embedding for it. So embeddings, which is this right here, we are going saying using the method dot embed query to create an embeddings for it, basically converting this text into basically numbers or vectors that we can use to search other vectors instead of our database, like our collection. So I'm going to create a variable called response, where I'm going to store all the response that we get back. So we say client.search, client.search. So in here, we need to put in a collection name. Basically, the collection name that you want to search is this right here. So let me just go ahead and grab the collection name. So collection name. So you can even copy this whole point right here. So copy that whole point, and I'm going to go down here and say collection name, paste that in there. So we are passing the collection name. Now we need to pass in the query filter. And the query filter just basically help us to filter things. So query underscore filter is going to be equals to models dot filter, and models we have it already imported. Okay, so models dot filter, and in here we're going to go ahead and pass in one value. So we're going to pass in must, basically must, and then it's going to be equals to Python list. Instead of this list, you're going to have the following. We're going to have the models dot condition. So models dot field condition condition. So make sure you watch out for the casing, right? So models condition, and then finally you're going to go ahead and pass in which of the fields that you want to search. I'm going to say key. The key should be equals to data set. And why am I using data set? Because the data set part is the part that has the separation of either being MongoDB embedded movies 1 or MongoDB embedded movies 2, right? So that's basically what you are filtering on. So you're passing the column that you want to filter on. So in this case, if you have real users, then you have like a users emails column. So you have filter based on the user email, right? In this case, you just have a dummy collection name that you're working with, basically the dummy username, which is MongoDB embedded movies 1 and MongoDB embedded movies 2. So we say match, and match is going to be equals to, I'm going to say models dot match values, just like this, match value, and then finally you're going to go ahead and pass in the following. So I'm going to say value is going to be equals to MongoDB, basically what you want to, which tenant you want to search for. That's the whole idea of multi-tenancy. So I'm going to say MongoDB underscore embedded underscore movies underscore 2, or let's say 1 in this case. So embedded movies underscore 1. Good. So that's basically what we are passing in here. Yeah, so once we have that specified in there, I'm also going to go ahead and pass in the query vector. And the query vector is the vector you just created, which is this object right here. So we say query underscore vec. Okay, let me just get that query vector, and it's going to be equals to the following. So I'm going to use the Python tuple right here. And the reason why we're using a Python tuple is, let me just scroll up here and explain this to you. So scroll a bit down, all the way down here. So we're having a dictionary that has key and a value pair. So we're going to go ahead and say we're going to filter on this column which has the embeddings, and then pass in what you want to search against that column. So I'm going to say this, and what do you want to search against this column, which is just the query underscore vector. That's basically it. And this needs to be a tuple. So since a single element tuple, we need to have this right here, this comma right here. If you don't have that, it's not gonna work. Okay, so it's gonna be needs to be a single element Python tuple, and that's how you create a single element Python tuple. And you're going to say the limit, and the limit you can limit to be like 5, 5, 5, 6, 7. It's just any integer number. It's just like the way you have limit in Postgres or MySQL or any other of these relation database management systems. It's the same concept right here. Okay, good. So once we have all the responses, we can go ahead and simply print out the response on the screen. So we call it a response or responses or response. Good. So once I have that, I can just run that, and that's going to go ahead and print the response onto the screen, so we can get back this response right here. Good. And the funny thing is that since we are only filtering based on the MongoDB embedded movies 1, is only going to return to us results from that specific collection. So MongoDB's underscore embedded movies 1 and 2 are completely isolated. So you can think of this as user emails or user names. They'll be completely separated from each other, and that's the whole idea of multi-tenancy, right? Yeah, so you can even check out that information if you want to. So let me just write it right here. Let's write a simple Python list. So for R in response, I'm going to go ahead and simply print the response. This response comes with this value payload, and from the payload we can get all the columns from the data frame. So when you say print, you're going to say r.payload, and you're getting the embedding section. So there's going to say embed. No, I'm going to get the data set, which is just now the information, the data set information, which is going to show us how we have implemented multi-tenancy. So since we have specified here only one, we are getting back only one user being selected. But if you change this to be let's change this to be 2. Let's run this. We should now get back a new value right here for responses. Like this will just run. Okay, we get back the new values. So if I go back and run this again, now this should be 2, only 2, not any other. So only 2. So this should now change all of it to be 2. So this, now you can see now how data is being isolated. So it demonstrates the whole concept of multi-tenancy in Qdrant or any other vector or multi-quadrants multi-tenant system. So you can see how that works, right? And you can also go ahead and print the IMDb. So IMDb, IMDb, and let's run this. Let's see what we get back. So we are searching for movies that have an IMDb rating of 3.6 and action, that are action movies. So if I go up here, you can see rating is 4, this is 6. Okay, this is a bit below 6, right? So it looks like user 2 doesn't have movies which have rating of above 3.6. But if I change it to be user 1, let's run this, and let's run this. Let's see what we get back. So let's wait for this to run. Once this is run, this also should run. Now you can see now the second user right here, tenant, has more movies that are greater than 3.6 and 3.6.3 and above. So you can see we have the ratings right here. So you can check different forms. You can check the awards, you can check the cast, you can check the countries, you can check the directors, you can check the full plot. There's just a ton of information right here, and you can use all this to build a chatbot system, right? So in this case, I'm just showing you how to query it, but in the real world, you might want to use this to build a chatbot system. Yeah, so let's look at now the pros and cons of using this. So let's start with the cost. So uh, a single tenant system is just that we have the same infrastructure, but now it's used by only a single user. But multi-tenancy application, we have the same infrastructure but used by multiple people, so the cost can be distributed to multiple users. So it's relatively cheaper compared to a single tenant architecture. What about data security? Now in a single tenant system, you have absolute data isolation. It's just for a single user, so the guy has absolute control over the data. But for multi-tenancy architecture, the data isolation is enforced through strict rules, like the way we have in our case right here. If I take you back here, we have strict rules specifying from which from which tenant you're getting the data from, right? And let's go on to the core performance. So multi-tenant application performance is really, really fast because there's no resource sharing. But in single tenant system is fast because there's no resource sharing. But multi-tenant system, it's really slow, can be slow, not really slow, can be slow because of resource sharing, right? Yeah, so guys, thank you guys so much for watching. That's all I wanted us to cover in this video. So if you like the video, one of the simplest way you can support the channel is by liking this video or sharing this content with anyone who you think might find it helpful. So you can also follow me on Medium, where I write articles about this content. In fact, I have an article about this video on Medium at Prince Cramper. You can also follow me on YouTube at Prince Code with Prince, where you're actually watching this video from. Or you can follow me on X at Prince_Cramper, or what we called Twitter previously. You can also follow me on LinkedIn at Prince Cramper. If you have any questions, you want to build anything that you need help with, uh, you just have to have a chat. You can always reach out to me on Twitter. You can also reach out to me on LinkedIn. Okay. You can also follow me my articles if you like reading on Medium. So thank you guys so much for watching. And if you want to support the channel further, you can even buy me coffee. The link is gonna be in the description of the video. So thank you guys so much for watching, and let me know of any feedback that you have, any questions, anything that's not clear. And all the GitHub repository links are gonna be in the description of the video, so you guys can have access to the code. Okay. So guys, thank you so much for watching, and see you in the next one. Keep safe.